There isn't really much new in the form of concepts or theory here in this module. We will continue with the dynamics analysis of the motion of objects. The new element here is that we will consider systems of objects, or really two objects together. The simplest case, and it's actually the first example, first video from this module, will be two blocks next to each other in physical contact. The important thing here is to recognize that both objects change their position in an identical manner, and that leads to their displacement always being equal to each other, moving with identical velocity and identical acceleration. For those of you who are familiar with calculus, this can actually be easily seen if you mark the displacement for both objects as delta x1 and delta x2 and require them to be equal to each other. Then a differentiation with respect to time will actually give you a relationship for their velocities. V1 also has to be equal to V2. Another differentiation will give you the relationship between their acceleration, that A1 has to be equal to A2. This is actually pretty intuitive and obvious for us, that the two objects will have the same acceleration. Here's a situation where it might not be so intuitive, especially if you're not very experienced with solving physics problems. When you have two objects that are connected with a rope, the rope will effectively couple their motion as long as it's inelastic, so it's a rope that doesn't stretch will enforce their a coupling between the motion of the two objects. For instance, if A goes up 1 meter, B has to go down 1 meter. And so even though the displacement, you will see displacement going in different direction, and their velocity and accelerations as vectors will be pointing in different directions, the magnitude actually of their displacement, velocity, and acceleration will change in identical manner at any given instant. So in this type of scenario situations, we always keep in mind that the magnitude of the displacement of both objects will be equal, the magnitude of their velocity will be equal, and the magnitude of their acceleration. One final comment here: when we're working with pulleys, all the pulleys in this module will be massless and frictionless. That ensures that the tension in the rope will always be the same, regardless of whether you're working with the segment of the rope on the left or on the right side of the pulley.